Hello students, in this video I would like to explain few questions and answers from the chapter Haloalkane and Haloarenes. Let us see the slides. In this slide, the question number 1 given as predict the dehydrohallucination product of the following compounds when treated with sodium ethoxide in ethanol. Now, sodium ethoxide is behaving like a base in ethanol medium. Now, when number 1 bromo 1-methyl cyclohexane, this one is treated with sodium ethoxide in presence of ethanol, then the dehydrohallucination products possible are these two. Now among these, this one will be the major product and this one will be the more stable, as because there is number of hyperconjugable hydrogen atoms are more. So uh, this is the product. Next one, uh, here it is, it must be 2. Now uh, in the next one, that is in case of 2-chloro-2-methyl butane. 2-chloro-2-methyl butane in this dehydrohallucination reaction can give these two products. Among these, we can find that the first one is the major one, as because it is ZJ product and it is more stable. Due to, again, you find that there is 3 and this 3, total 9 hyperconjugable hydrogen atoms, whereas in this case there is only 5 hyperconjugable hydrogen atoms, these 3 and these 2. That's why it is less stable. So this is the major product. Now the next one is 2,2,3 trimethyl 3-bromo pentane. This is the structure of the substrate. Now when it is treated with alcoholic sodium ethoxide, the base, it can give these two alkenes. Among these, this one is the major product. So in this type of questions, we have to predict which one will be the major product, and for that we need to use the concept of hyperconjugation, and also you have to use the concept of Morse substituted alkene called the ZJ product. That will be the major product. Now let us find few conversions in the second question. Few conversions as it is given here. Propene to propan 1-ol. So propene is this one. Now the OH group has to be there at the first carbon. For that we can prepare from propene by anti-Markovnikov process 1-bromo propane. When it is propene is treated with HBr, as we know that anti-Markovnikov is carried out only in presence of HBr, in presence of any peroxide like hydrogen peroxide. So 1-bromo propane is the product. When it is treated with aqueous alkali, aqueous KOH or NaOH, then a nucleophilic substitution reaction takes place, giving this 1-propan 1-ol. Next is ethanol to but-1-ion. Now ethanol is this one and but-1-ion is this one. So to bring this alkyne group, we can perform this reaction. First we can displace OH group with halogen chlorine, and then this one, this is sodium ethionide. If we directly use that, this will behave as the nucleophile displacing the Cl, giving rise this product. So this is the second one. Next one is benzene to diphenyl. Benzene to diphenyl. For that, we can take the help of fatigue reaction. Therefore, primarily we need to bring halogen in the benzene ring. That is, first halogenation of benzene gives chlorobenzene. Say here it is chlorination takes place. Chlorobenzene, when treated with sodium in presence of dry ether, then it gives rise the diphenyl. So this is the second step. One is the fatigue reaction. We can take the help of fatigue reaction. Next one is 1-bromopropane to bromopropane. That means the bromine was there at the terminal carbon of this propyl group. Here the bromine has to be there at the second carbon. It has to bring at the second carbon. Now for that we first perform the dehydrohalogenation when it is treated with alcoholic KOH, giving rise this alkene, and then simple Markovnikov addition of HBr gives rise this to bromopropane. Then number 5 is toluene to benzyl alcohol. Now toluene, when treated with, it is performed with halogenation. That means halogen in presence of sunlight or heat. Then the substitution at the side chain takes place. In this case, this reagent cannot bring halogen in the benzene ring. Rather, substitution at the side chain giving rise this benzyl chloride when it is carried out with aqueous, nucleophilic substitution with aqueous alkali, then we can get benzyl alcohol. Next, benzene to 4-bromo-nitrobenzene. So here two groups are coming in the benzene ring, bromine, Br, and the NO2 group. So first of all, we have to think that this NO2 group is coming at the para position of halogen, as halogen is orthopara directing group. So primarily we can perform halogenation, that means bromination, and then nitration. Since bromine is orthopara directing group and para product is the major product, therefore we can get 4-bromo-nitrobenzene. Next, benzyl alcohol to 2-phenyl ethanoic acid. Benzyl alcohol to 2-phenyl ethanoic acid means here we need to increase the number of carbon atoms. For that, we can use KCN to bring new carbon atoms, and beforehand we have to substitute the OH group from the alcohol with halogen, so that this halogen group can be substituted with CN when treated with KCN, and then on catalytic hydrogenation, hydrolysis, hydrolysis in acidic medium of this cyanide group gives the carboxylic acid. So in this way we can transform benzyl alcohol to 2-phenyl ethanoic acid. Now next one is aniline to chlorobenzene. Aniline, when treated with sodium nitrite and concentrate HCl at low temperature 0 to 5 degrees Celsius. So the product is benzene diazonium chloride. Now this diazonium chloride, aromatic diazonium group are stable. So this is the benzene diazonium chloride formed, and when it is carried out with Sandmeyer reaction, CuCl or Cu2Cl2 in presence of HCl, we can get chlorobenzene. Next one is but1-ene to normal butyl iodide. Now in this reaction, we can follow that the iodine group is coming at the terminal carbon. So here what we can take the help of anti-Markovnikov rule to bring first bromine, as we know that anti-Markovnikov is carried out only in presence of HBr. So bromination in presence of peroxide gives 1-bromobutane, and when this is 1-bromobutane is treated with sodium iodide in presence of dry acetone, that means Finkelstein reaction is carried out, then bromine is being substituted with Br group is substituted with iodide. So our desired product can be obtained. Next is isopropyl chloride to iodoform. Now this isopropyl chloride, first of all, when treated with aqueous alkali, nucleophilic substitution gives rise propan-2-ol isopropyl alcohol. Now this isopropyl alcohol has got a group CH3CHOH. We know that alcohol containing this group, when treated with sodium hydroxide in presence of iodine, rather when it is heated with iodine and NaOH, then iodoform is formed. That means this CH3 group is changed to CHI3, and rest of the carbon, that means 2 more carbons are there, this group is converted to carboxylic acid, salt of carboxylic acid. So in this way, isopropyl alcohol can be changed into iodoform. The next one is aniline to phenyl isocyanide. Now, this simple reaction is the carbylamine reaction. It is a carbylamine test also for the identification of primary amine. So, this aniline is a primary amine. When treated with chloroform in presence of alkali and it is heated, then phenyl isocyanide is formed, that is having a characteristic bad smell by which it is identified. Now, the last one is from tertiary butyl bromide to isobutyl bromide. So we can follow the tertiary butyl bromide is having this bromine atom at the middle carbon, and simply here the bromine has to be taken at the terminal carbon. For that, we can perform the dehydrohalogenation process by treating tertiary butyl bromide with alcoholic KOH, giving rise to methyl propene. And when it is treated with HBr in presence of peroxide, following the anti-Markovnikov rule, isopropyl bromide is formed. Thank you.